Derivative. The derivative is the instantaneous rate of change of a function with respect to one of its variables. So, four-step rule in differentiation. 1. Substitute x plus delta x for x and y plus delta y for y. 2. Subtract y equal to fx from the results of step 1. Then 3. Divide both sides by delta x. 4. Find the limit as x approaches 0. X plus delta x and y for delta y. In y equals to f of x. So substitute. So you have this one. Y plus delta y equals to x plus delta x squared, or y plus delta y equals to x squared plus 2x delta x plus delta x squared. Then the next is substitute or subtract y f of x from the result of step 1. So we have this one, x squared plus delta y equals to x squared plus 2x delta x plus delta x squared, or delta y equals to 2x delta x plus delta x squared. Both sides by delta x. So that one, delta y over delta x equals to 2x delta x plus delta x squared divided by delta x equals to 2x plus delta x. Then dy over dx equal to the limit delta y over delta x equals to 2x plus 0 as delta x approaches 0. So dy over dx equals to 2x. Find dy over dx of y equals to 2 plus x squared plus 2. So substitute x plus delta x and y plus delta y for y. So we have this one, y plus delta y equals to 2 plus x plus delta x squared plus 2 times x plus delta x equals to 2 plus x squared plus 2x delta x plus delta x squared times plus 2x plus 2 delta x. So substitute the value. So we have that 1, 2 plus x squared plus 2x plus delta y equals to 2 plus x squared plus 2x delta x plus delta x squared plus 2x plus 2x plus 2 delta x, so equivalent to, for delta y equals to 2x delta x plus delta x squared plus 2 delta x. So divide both sides by delta x. So delta y over delta x equals to 2x delta x plus delta x squared plus 2 delta x divided by delta x, so equivalent to 2x delta x, 2x plus delta x plus 2. So find the limit as delta x approaches 0 to delta y over delta x equals to dy over dx equals to 2x plus 0 plus 2, for c dy over dx equivalent to 2x plus